Welcome to the Sleepy Academy. You have arrived at a sanctuary designed for rest, a quiet corner of the world where the noise of the day simply fades away. Here, we believe that true relaxation comes from the gentle rhythm of words and the soothing cadence of a narrative told without haste. Before we drift into tonight's journey, if you find comfort in this space we have created, please consider gently pressing the like button. It helps other weary souls find their way to us. And if you wish to return here for future nights of deep rest, we invite you to subscribe to our channel. Now, take a moment to make yourself comfortable. Adjust your pillows, let your shoulders drop, and allow your breathing to slow down. Close your eyes, clear your mind, and let us begin. The architecture of distance. In the vast, silent stretches of the night sky, where the darkness seems to go on forever, there exists a measurement that defies our ordinary understanding of the world. It is a concept born from necessity, arising when the tools we use to measure our daily lives simply cease to function. We call this measurement the light year. On the surface, the phrase sounds familiar. It is composed of two words that we use every day. We know what light is. We see it filter through the curtains in the morning. We watch it cast shadows across the floor in the afternoon. We rely on it to navigate our rooms when the sun goes down. And we know what a year is. We feel it pass in the changing of the seasons, in the slow growth of trees, in the turning of calendars. These are comfortable words. They are human words. But when they are combined into the single unit of astronomy, they create something that sits strangely in the mind. A light year sounds like a measure of time. It has the word year right there at the end, suggesting a duration, a period of waiting, a long stretch of hours and days. But it is not a measure of time. It is a measure of distance. It is a phrase that carries more physical space than the human mind was ever designed to hold. It is the distance that light, moving at its unwavering cosmic speed, can travel in a single year of uninterrupted motion. To understand what this really means, and to understand why we need such a strange unit, we must first look at how we understand distance itself. We must look at the ground beneath our feet and the way we move through the world. Distance for us has always been physical. It is tactile. It is something we feel in our bodies. For thousands of years, to know a distance was to know the effort required to cross it. A short distance was a few steps across a room. It was the time it took to walk from the hearth to the door. A medium distance was a walk to a neighbor's house, or perhaps a journey to the nearest river. These distances were measured in strides, in the rhythm of breath, in the tiredness of legs. If a place was far away, it meant that you had to pack food. It meant that you had to wait for the weather to clear. Distance was an obstacle. It was something that resisted us. It was tied inextricably to the speed at which a human being could walk. Even as we began to build tools to help us move, our sense of distance remained anchored to the earth. We built ships to cross oceans, and we measured the journey in days and weeks. We watched the coastline fade and waited for a new coastline to appear. The ocean was vast, certainly, but it was still a surface. It was still something that could be traversed. Later, we built trains that cut through the landscape, blurring the trees and fields, compressing the time it took to travel between cities. Then came cars, and eventually airplanes, which shrank continents into a matter of hours. But through all of this, distance remained something we could conquer. It was a problem to be solved with speed. If a place was far away, we simply moved faster. We built better engines. We paved straighter roads. We defined distance by how long it took us to get there. But space is different. Space does not cooperate with our instinct to conquer it. When we look up at the night sky, we are looking at a realm where our traditional understanding of movement begins to fail. Beyond the atmosphere of our planet, the familiar units of kilometers and miles begin to stretch thin. They are designed for roads and maps, for borders and bridges. They are not designed for the void. As we move away from the Earth, past the orbit of the Moon and out towards the planets, the numbers we use to describe distance start to become unmanageable. They grow so large that they lose their meaning. We can write them down. We can say that a planet is millions of kilometers away. We can say that a star is trillions of kilometers away. The mathematics are precise. The numbers are correct. But the human mind cannot truly hold them. When we hear a number like 1 trillion, we might nod politely. We might acknowledge that it is very big, but we do not feel it. It becomes abstract. It becomes just a string of zeros on a page, conveying precision but not understanding. The mind blurs. The imagination retreats. This is where the light year becomes essential. It emerged not as a poetic invention to make the universe sound romantic, but as a practical necessity to keep astronomers sane. It was a way to describe the separation between stars without drowning in digits. It was a way to take the unimaginable scale of the cosmos and fold it into a unit that we could speak aloud without stumbling. To approach the idea of the light year, we must slow down. We must let go of the need for speed and the need for arrival. Tonight, we are not racing across the galaxy. We are drifting. We are allowing the concept of distance to unfold at its own pace, layer by layer, until we can sense the quiet vastness that lies between the stars. We begin with the familiar. We begin with the limitations of our own intuition. It is important to remember that human intuition was formed in a very narrow range of experience. Our ancestors did not need to understand the scale of the universe to survive. They needed to know how far a predator was. They needed to know if a shelter was close enough to reach before nightfall. They needed to know if a fruit tree was within a manageable radius for gathering. Our brains evolved to handle distances that mattered to our survival. We became experts at judging depth within a few hundred meters. We learned to lead hawks would take. We learned to read the terrain. But evolution gave us no tools for emptiness. It gave us no reason to prepare for a void stretching millions of times farther than the horizon. When we try to visualize the distance to a star, we are using a mind that was built to visualize the distance to a watering hole. It is a mismatch of machinery. It is like trying to measure the depth of the ocean using a wooden ruler. It is not that the ruler is wrong, it is simply that the ocean is operating on a completely different scale. This is why space feels so strange to us. It is not just big, it is fundamentally disconnected from effort. On Earth, if you walk long enough, you will eventually get somewhere. You will see the landscape change. You will pass landmarks. You will feel the progress in your muscles. In space, you can travel for 1,000,000 kilometers and see nothing change at all. The stars will look exactly the same. The darkness will look exactly the same. There is no wind to feel against your skin. There is no road passing beneath your feet. There is only the sensation of floating, of drifting through a silence that has no edges. This absence of landmarks strips distance of its texture. It becomes smooth. It becomes silent. It becomes difficult to sense.
3. This is the environment where the light year lives. It is a unit of measurement for a place where walking is impossible and where driving would take eternity. To understand it, we have to look at the fastest thing we know. We have to look at light itself. Light is so familiar to us that it almost disappears into the background of our lives. It fills our rooms when we wake up. It reflects off the surfaces of our tables and chairs. It delivers the colors of the world to our eyes. It seems instantaneous. When you flip a switch, the lamp turns on immediately. When you open your eyes, the world is just there, waiting for you. It does not feel like light is traveling. It feels like light is simply present. But light is not static. It is a traveler. It is a stream of energy moving through space at a specific, finite speed. It is not infinite. It does not happen everywhere at once. It flows. It ripples outward from its source like a wave moving across a pond, only much, much faster. Physicists discovered long ago that light travels at a speed that is woven into the fabric of the universe itself. It moves at approximately 300,000 kilometers every single second. Even that number is hard to visualize. 300,000 kilometers in 1 second. To put that into perspective, in the time it takes for your heart to beat once, light could circle the entire Earth 7 times. It is a speed that defies our instincts. It is so fast that for all practical purposes on Earth, it might as well be instant. But space is so vast that even this incredible speed begins to look slow. And this is the key to understanding the light year. It is the realization that the universe is so large that even light needs time to cross it. When we leave the surface of the Earth, the delays begin to appear. The moon, our closest companion in the night sky, is close enough that we can see the craters on its surface with a pair of binoculars. It looks like it is just right there, hanging just above the trees. But the moon is roughly 384,000 kilometers away. It is a distance that light, moving at its unimaginable speed, takes just over 1 second to cross. If you were standing on the moon and you flashed a light toward Earth, a person watching from their garden would not see it instantly. They would have to wait. 1 second. It is a tiny pause, a heartbeat, a blink, but it is there. It is the first hint that distance is transforming into time. As we move further out, the pause grows longer. The sun, the source of all our warmth and daylight, sits about 150 million kilometers away. That distance is enormous, but in the language of light, it is measured in minutes. It takes sunlight about 8 minutes and 20 seconds to travel from the surface of the sun to the surface of the Earth.
4. This means that the light warming your skin on a summer afternoon is not fresh. It is 8 minutes old. It has been traveling through the cold vacuum of space while you were making breakfast, or while you were reading a book, or while you were simply sitting still. It began its journey, and it crossed the void, and it arrived 8 minutes later. If the sun were to suddenly vanish, we would not know it for 8 minutes. We would still see it shining in the sky. We would still feel its gravity holding us in orbit. We would be living in the past, blissfully unaware that the source of our light was gone, until the last stream of photons finally arrived and the sky went dark. This delay is the foundation of the light year. It teaches us that looking out into space is really looking back in time. It teaches us that distance is not just a gap between two objects, it is a lag in information. It is a waiting period. And as we move beyond the sun, past the orbits of Mars and Jupiter and Saturn, the waiting period stretches from minutes into hours. By the time we reach the edge of our own solar system, light takes hours to reach us. But even here, we have not yet reached the scale of a light year. We are still in the local neighborhood. We are still standing on the front porch of the cosmos. To reach the scale where light years become necessary, we must leave the solar system behind. We must cross the deep, empty ocean that separates our star from the next nearest star. This is where the true nature of emptiness reveals itself. The distance between stars is so great that kilometers become utterly useless. Describing the distance to the nearest star in kilometers would be like measuring the distance around the equator in millimeters. You could do it mathematically, you could write down the number, but it would be a number so long, so cluttered with zeros that it would convey nothing but confusion. And so, astronomers use the light year. They ask, if light travels at 300,000 kilometers per second and it never stops and it never slows down, how far would it get if you let it run for an entire year? The answer is a distance of about 9.5 trillion kilometers. That is 1 light year. It is a distance that is impossible to visualize. Our brains simply shut down when we try to picture a trillion of anything. But we don't need to picture the kilometers. That is the beauty of the unit. We only need to picture the time. We only need to imagine a beam of light moving silently, steadily through the dark for 1 full year. Think of the patience in that movement. Think of a year in your own life. Think of all the things that happen in 12 months, the changing of seasons from winter to spring, to summer to autumn and back to winter again. Birthdays, holidays, projects started and finished, relationships changing, books read, meals eaten, nights of sleep. A year is a long time for a human being. It is a significant portion of our experience. Now imagine that for that entire time, through every minute of every day of that year, a beam of light has been rushing through space. It has not stopped to rest. It has not slowed down for traffic. It has moved at the absolute cosmic speed limit, covering 300,000 kilometers with every tick of the clock. And at the end of that year, the distance it has covered is 1 light year. That is the measuring stick we use for the universe. It is a ruler made of time and speed. And the most humbling part of this concept is that the nearest star to us, a faint red star called Proxima Centauri, is not 1 light year away. It is more than 4 light years away. The light we see from that star tonight left its surface 4 years ago. It has been traveling through the emptiness while we lived 4 years of our lives. It is a message that has been in transit since the recent past, carrying the image of a star across a gap so wide that physical travel is almost inconceivable. This is why the light year is such a quiet, relaxing concept. It forces us to accept that we cannot rush. The universe is built on scales that demand patience. It is built on distances that make our fastest jets and rockets look like they are standing still. If we were to get into a car and drive at highway speeds, roughly 100 kilometers per hour, and we tried to drive 1 light year, we would have to keep driving for more than 10 million years. The human species has not even existed for 10 million years. We would have to drive through the rise and fall of civilizations, through the shifting of continents, through the evolving of the planet, just to cover the distance that light covers in 1 single year. This comparison helps us let go of the idea of conquering space. It helps us settle into the idea of witnessing it. We are not travelers on these scales. We are observers. We are watchers. We are sitting on a small, quiet rock, looking out into a vast, dark ocean and catching the waves of light that wash up on our shores. And each wave tells us how far it has traveled by how long it took to arrive. The light year tells us that the universe is deep. It tells us that the universe is old. It tells us that everything we see is a memory. In the chapters to come, we will drift further out. We will move beyond the nearest stars, out to the edges of the galaxy, and then into the profound emptiness between the galaxies themselves. We will see how this single unit, the light year, stretches to accommodate the mind-bending size of the cosmos. We will explore what it means to look millions of years into the past. We will find comfort in the fact that we are small and that the universe is large, and that there is a slow, steady rhythm to the way information moves through the dark. But for now, we simply acknowledge the first step. We acknowledge that distance is not just space. Distance is time, and the light year is the bridge that connects them. 6. The training ground of seconds and minutes. Before we can truly understand the vast, silent ocean of the light year, we must first learn to swim in the shallower waters of our own home. We must understand the local neighborhood. In astronomy, local is a relative term. To a human being, local means the street outside the window or the town down the road. To the universe, local means the solar system. It means the family of planets, moons, asteroids, and comets that circle our sun. Even here, in this relatively small pocket of space, the distances are already growing beyond what our minds can comfortably grasp in kilometers. We are used to seeing the solar system in diagrams in school textbooks. In those pictures, the planets are lined up neatly in a row. They look like colorful marbles sitting on a table, close enough to touch one another. Mercury, Venus, Earth, Mars, they seem crowded. But those diagrams are lies of necessity. They have to squeeze everything onto a single page, so they remove the one thing that defines space more than anything else, the emptiness. If we were to draw the solar system to scale and we made the Earth the size of a peppercorn, the Sun would be a ball of gas roughly the size of a bowling ball, and it would be 26 meters away. Jupiter would be a chestnut more than 100 meters away. Pluto would be a grain of sand located a full kilometer away. And in between these tiny specks of matter, there would be nothing but empty, silent air. This is why we need light to measure even our own backyard. We need a ruler that can span the silence. And so we begin to measure not in years, but in seconds and minutes. This is the training ground. This is where we learn that looking at the sky is an act of waiting. Let us start with the closest world to our own, the moon. It hangs in the night sky, large and luminous, covered in the gray scars of ancient impacts. It feels like a companion. It controls our tides. It lights our paths. It watches over us while we sleep. It feels near. And in cosmic terms, it is. But even this nearest neighbor is separated from us by a chasm of emptiness that defies easy travel. The Apollo astronauts, strapped into the most powerful rockets ever built by human hands, took 3 days to cross that gap. 3 days of drifting through the blackness. 3 days of silence. But light is faster. Light does not drift, it rushes. When we look at the moon, we are seeing light that left the lunar surface just over 1 second ago, 1.3 seconds to be precise. It is a distance of about 384,000 kilometers. In the time it takes to take a single deep breath, light can make that journey. It is a light second. This is a manageable unit. We can feel a second. We can understand it. It is the duration of a heartbeat. It is the time it takes to blink. When the astronauts on the moon spoke to Mission Control in Houston, there was a pause. They would say something, and their voice, carried by radio waves which travel at the speed of light, would take just over a second to reach Earth. Mission Control would hear it and answer immediately, but their answer would take another second to travel back to the moon. The result was a conversation filled with small, unavoidable gaps, a rhythm of waiting. Silence, voice, silence, answer. That silence was not a technical failure. It was the physical manifestation of distance. It was the universe gently reminding us that even close neighbors are not in the same room. Now let us turn our attention inward toward the center of our system, the sun. It dominates our sky, burning with a ferocity that sustains all life on our planet. It looks like it is right there. We feel its heat on our faces the moment we step outside. But that heat is an illusion of immediacy. The sun is 150 million kilometers away. It is a distance so vast that a commercial jet flying without stopping would take nearly 20 years to reach it.
7. Light, however, makes the journey in 8 minutes and 20 seconds. This is a light minute. It is a scale that fits into a human routine. 8 minutes is the time it takes to boil a kettle and make a cup of tea. It is the time it takes to listen to 2 slow songs. It is a short walk around the block. In that brief span of mundane time, light has crossed the cold, dark void between the star and the planet. It has raced past the orbit of Mercury, past the thick clouds of Venus, and arrived at our atmosphere. There is a strange and beautiful thought that comes with this delay. When you watch the sunset, when you see that great orange sphere touching the horizon, dipping below the edge of the world, you are watching something that has already happened. The sun has already set. Physically, geometrically, it is already below the horizon. But the light carrying the image of the sun is still streaming toward you, 8 minutes behind reality. You are watching a ghost. You are watching a memory of the sun. The universe is playing a trick on your eyes, preserving the moment for just a little longer than it actually existed. As we turn our backs on the sun and look outward into the deeper dark of the outer solar system, the light minutes begin to stack up. We move past Mars, the red planet. Depending on where Earth and Mars are in their orbits around the sun, the distance between them changes. Sometimes they are close, sometimes they are on opposite sides of the star. The time it takes for light to travel to Mars varies from about 3 minutes to nearly 22 minutes. Think of the rovers that crawl across the surface of Mars right now, robot explorers dusting the red soil. When engineers on Earth send a command to tell a rover to turn left or to take a picture, they press a button, but nothing happens. The signal leaves Earth, flashing out into the void at the speed of light. It travels for 10, maybe 15 minutes. It crosses millions of kilometers of nothingness. Finally, it arrives at Mars. The rover receives the command and turns left. It sends a signal back saying, "I have turned." That signal takes another 15 minutes to return to Earth. For the engineers sitting in their chairs, a full half hour has passed since they pressed the button. They have to wait. They have to trust. They have to accept that they are not driving the rover in real time. They are guiding it through a delay. They are interacting with the past. This is the lesson of the solar system. The further you go, the deeper into the past you must reach.
Beyond Mars, the distances expand dramatically. We reach the realm of the gas giants. Jupiter, the king of planets, a swirling ball of storms and clouds so large that it could swallow 1,000 Earths. It sits far out in the cold. Light from the sun takes roughly 43 minutes to reach Jupiter. 43 minutes, that is a lunch break. That is a television episode. It is a significant chunk of an hour. If someone were floating in the clouds of Jupiter, looking back at Earth with a telescope, they would not see us as we are now. They would see us as we were 43 minutes ago. They would see us doing things we have already finished doing. Then comes Saturn with its magnificent icy rings. Saturn is nearly twice as far from the Sun as Jupiter. The light takes about an hour and 20 minutes to get there. An hour and 20 minutes of silence. An hour and 20 minutes of moving through the dark with no landmarks, no air, no sound. Just the steady, unwavering progress of photons flying away from the Sun. And then the ice giants, Uranus and Neptune. These worlds are so distant that they are barely visible to the naked eye, faint points of light lost among the stars. Sunlight takes nearly 2 hours and 40 minutes to reach Uranus. It takes over 4 hours to reach Neptune. 4 hours. Imagine standing in the sunlight at noon. That same light, that same pulse of energy will not touch the clouds of Neptune until 4 o'clock in the afternoon. It is a journey that spans half a workday. By the time we reach Pluto and the scattered icy rocks of the Kuiper Belt, we are 5.5 hours away from the Sun at light speed. The Sun from Pluto is no longer a blinding disk. It is just a very, very bright star in a black sky. It provides little heat. The daylight on Pluto is weak and watery, like the light of dusk on Earth. The delay is profound. A message sent from Earth to a probe near Pluto takes 5.5 hours to arrive. A round trip takes 11 hours. You could send a message in the morning, go about your entire day, eat dinner, and get ready for bed before the reply returned. This is the scale of our own neighborhood. It is measured in hours. It is vast, yes. To a human being, it is inconceivably large. But to the universe, it is nothing. It is a speck. It is a grain of dust. Because even at Pluto, even at the edge of the darkness where the Sun's influence begins to fade, we have not yet reached a single light year. We haven't even come close. A light year is not 5 hours. It is not a day. It is not a week. It is a year. 8,760 hours. To reach 1 light year, you would have to travel the distance from the Sun to Pluto roughly 1,600 times. You would have to stack 1,600 solar systems end to end just to span the distance that light travels in 1 year. And remember, the nearest star is over 4 light years away. This is where the brain begins to stumble. We feel like we have traveled a long way just to get to Pluto. We have crossed billions of kilometers. We have passed giant planets and asteroid belts. We have spent hours moving at the speed of light, and yet we have barely left the driveway. We are still standing on the doormat of the cosmos. The distance between the edge of our solar system and the very next star is a void so deep, so wide, and so empty that it makes the distance between the planets look like a crowded room.
In that void, there are no planets to mark the way. There are no rest stops. There is only the drift. There is only the long, silent glide through the interstellar medium, the thin soup of particles and dust that fills the space between stars. This is where the light year truly begins to matter. It is where light minutes and light hours become too small to be useful. We need a bigger ruler. We need a ruler that can handle the silence of the deep ocean. Consider the Voyager probes, Voyager 1 and Voyager 2, launched by humanity in the 1970s. They are the fastest objects ever built by human hands. They have been flying for over 45 years. They have flown past Jupiter, past Saturn, past Uranus and Neptune. They have left the planets behind. They are moving at roughly 60,000 kilometers per hour,
a speed that is terrifyingly fast by Earth standards, and yet in light years, they have traveled nowhere. They have traveled less than 1 day of light time. They have been flying for nearly half a century, and they have not even covered the distance light covers in 24 hours. If Voyager 1 were heading directly toward the nearest star, which it isn't, but if it were, it would take over 70,000 years to get there. 70,000 years. That is the difference between chemical rockets and the speed of light. That is the difference between human movement and cosmic scale. It is a reminder that we are slow and the universe is big. But there is a comfort in this slowness. There is a peace in knowing that we cannot rush. We cannot force the universe to be smaller than it is. We can only watch it. We can only listen to it. The solar system, with its light minutes and light hours, teaches us patience. It prepares us for the longer waiting that is to come. It teaches us that separation is natural, that delay is built into the physics of reality. When we look at Saturn, we are waiting for an hour. When we look at Neptune, we are waiting for 4. We are practicing. We are letting our minds stretch, slowly, gently, like a muscle warming up. We are getting ready to look beyond the edge, into the true dark, where the light takes not hours, but years and centuries and millennia to reach us. So let us rest here for a moment. Let us drift in the space between the planets. Let us float in the 4-hour gap between the Sun and Neptune. It is quiet here. It is calm. There is no wind. There is no noise. There is only the faint, distant warmth of the star and the endless velvet black of the vacuum. We have learned the scale of minutes. We have learned the scale of hours. We are ready now to turn our eyes outward to the places where the calendar becomes the clock and the light year becomes the only way to speak of the distance home.
10. The ocean between the islands. We have left the planets behind. We have drifted past the icy giants, Uranus and Neptune, and we have floated silently through the scattered debris of the Kuiper Belt, where Pluto and its frozen cousins wander in the dark. Now we are crossing a boundary. It is not a solid wall, nor a line drawn on a map. It is a fading. It is the place where the wind from the sun, the stream of charged particles that blows outward from our star, finally loses its strength. It pushes against the thin, sparse gas of the galaxy, and it falters. This is the edge of the heliosphere. This is the true border of our home. Beyond this point, we are in interstellar space, the space between stars. If the solar system was a house, we have just stepped off the front porch and into the night. And the first thing we notice, the overwhelming sensation that defines this new realm, is emptiness. When we were near Earth, space seemed busy. There were satellites, debris, the moon, the other planets visible as bright wandering lights. Even in the outer solar system, there was a sense of structure. We knew the sun was there, holding everything in place with its invisible gravitational tether. But here, in the deep void, that structure feels distant. The sun is just a star now. It is the brightest star in the sky, yes, but it no longer dominates. It has become a point of light, shrinking with every moment of travel, merging into the backdrop of the Milky Way. We are entering the ocean between the islands. The distances here are so vast that they defy the analogies we used before. We spoke of light minutes and light hours. Those units are now too small. They are like trying to measure the depth of the Pacific Ocean with a teaspoon. We must switch to the light year, and even then the numbers are humbling. The nearest star system to our own is the Alpha Centauri system. It is not a single star, but a family of 3. There is Alpha Centauri A, a bright yellow star much like our sun. There is Alpha Centauri b, a slightly smaller orange star. And there is Proxima Centauri, a small, faint red dwarf that circles the other two from a great distance. Proxima is the closest of them all. It is our nearest cosmic neighbor, and it sits at a distance of roughly 4.2 light-years. 4.2 light-years. Let us hold that number in our minds. It sounds small. 4 is a small number. You can count to 4 on one hand. But remember what a light-year is. It is 9.5 trillion kilometers. It is a year of continuous, breathless speed. To say that Proxima is 4 light-years away is to say that light, the fastest messenger in the universe, must travel for 4 years, 2 months, and a few weeks without stopping, just to cross the gap. Imagine a beam of light leaving the surface of Proxima Centauri. It flashes into existence, born from the swirling plasma of the star. It flies outward, escaping the star's gravity, and enters the void. For the first year of its journey, it encounters nothing. It flies through absolute darkness. There are no planets to pass, no asteroids, no dust clouds large enough to matter. It is just the photon and the silence. A year passes. On Earth, the seasons have turned. A birthday has come and gone. The light is still traveling. It has covered 9.5 trillion kilometers, and it is still in the middle of nowhere. It is not even halfway there.
A second year passes. The light rushes on. It is utterly alone. The silence of interstellar space is profound. There is no air to carry sound. There is no friction to slow it down. It is a perfect, frictionless glide. The light is as fresh and as bright as the moment it was born, preserved by the emptiness. A third year passes, then a fourth. Finally, after more than 50 months of travel, the light begins to approach our solar system. It crosses the heliosphere. It races past Neptune and Uranus. It flashes past Saturn and Jupiter. It crosses the orbit of Mars. And finally, 4 years and 2 months after it left its home, it strikes the lens of a telescope on Earth. It hits the retina of an astronomer's eye. And in that moment, the astronomer says, "I see the star." But they do not see the star as it is. They see the star as it was 4 years ago. They are looking at a ghost. If Proxima Centauri were to flare up today, if it were to release a massive burst of energy, we would not know about it for 4 years. The news is traveling, but it is stuck in the slow lane of the universe. We are cut off from the present. We are surrounded by history. This distance of 4 light-years is the closest anything gets to us. That is the stark reality of our position in the galaxy. We are isolated. The gaps between stars are not like the gaps between houses on a street. They are like the gaps between ships scattered across a lonely ocean. If the sun were a grapefruit in New York City, the nearest star would be another grapefruit in Los Angeles. And in between them, across the entire continent, there would be nothing but a few drifting molecules of gas. This isolation is why interstellar travel is so incredibly difficult. It is not just an engineering problem, it is a problem of scale. To bridge the gap to Proxima Centauri using our current technology would take tens of thousands of years. It would be a journey of generations. A ship launched today would drift through the silence for millennia. Civilizations would rise and fall on Earth. Languages would change. History would be written and rewritten. And all the while, the ship would be floating in the dark, barely moving relative to the scale of the distance it has to cross. But there is a beauty in this isolation. It means that each star is its own private island. Each star is a sanctuary. The events of one solar system do not easily spill over into another. We are safe from the storms of our neighbors. Gravity, which holds planets in their orbits, weakens over these vast distances. The Sun holds us tight, but it has no grip on Alpha Centauri, and Alpha Centauri has no grip on us. We drift past each other, separated by the cushion of light years, engaged in a slow, graceful dance around the center of the galaxy. Let us look deeper into this void. What is actually out there in the space between the Sun and Proxima Centauri? It is not truly empty. It is filled with the interstellar medium. This is a thin, tenuous soup of hydrogen and helium gas, mixed with tiny traces of dust. But when we say thin, we mean thin beyond comprehension. The air you are breathing right now contains billions and billions of molecules in every cubic centimeter. In the interstellar medium, you might find one atom in a cubic centimeter, one single, lonely atom floating by itself.
It is a vacuum better than anything we can create in our best laboratories on Earth. It is so empty that light can travel through it for thousands of years without ever hitting anything. It is so empty that it offers no resistance. It is the perfect environment for light to carry its message. This is why we can see the stars at all. If space were filled with air like our atmosphere, the light from distant stars would be scattered and absorbed long before it reached us. The sky would be a fog. We would see nothing but a gray haze. But because space is empty, the light remains pure. It cuts through the dark like a laser, preserving the image of its source across the abyss. As we drift through this region, we can imagine the view. Without the atmosphere of Earth to scatter the sunlight and turn the sky blue, the sky is always black. It is a deep, velvety black, studded with diamonds. The stars do not twinkle here. Twinkling is caused by the air on Earth moving and shifting. Here, in the void, the stars are steady, unblinking points of piercing light. They look hard and cold, and they are everywhere. Above, below, to the left, to the right, we are suspended in a sphere of stars. And yet, despite their numbers, they feel far away. They do not illuminate the darkness around us. If we were floating in deep interstellar space, far from any star, it would be pitch black. Your hand in front of your face would be invisible. The nearest star would be just a bright dot, offering no warmth. The cold would be absolute. The temperature sits just a few degrees above absolute zero. It is a deep, permeating cold that has existed for billions of years. This is the environment that light conquers. It travels through the cold, through the dark, through the emptiness, carrying the story of the universe. It connects the islands. It is the only connection we have. We cannot touch the stars. We cannot hear them. We can only see them. We are bound to them by these thin threads of light that stretch across the light years. When we look at the Alpha Centauri system, we are looking at a potential mirror of our own home. Astronomers have found planets orbiting Proxima Centauri, worlds that sit in the habitable zone where water might exist. It is tantalizing to think that just 4 light years away, just next door in cosmic terms, there might be a landscape of rocks and canyons, perhaps even an ocean. But that distance is a wall. We can see the light reflecting from it, but we cannot reach it. We can only wonder. The light year teaches us humility. It teaches us that we are small and that our reach is limited. But it also teaches us that we are part of a larger fabric. The light from Alpha Centauri falls on your eyes when you look up at the southern sky. The photons that traveled for 4 years end their journey on your retina. You are physically touching the universe. You are catching the rain of light that has fallen across the galaxy. As we move further out, beyond the nearest stars, the numbers begin to grow again. 4 light years becomes 10. 10 becomes 100.
We start to see stars not as individuals, but as clusters. We see the Pleiades, the Seven Sisters, a group of young, hot blue stars huddled together in the dark. They are 400 light-years away. The light we see from them left during the time of Galileo, when the telescope was first being turned toward the sky. We are watching them as they were centuries ago.
13. We see the Orion Nebula, a glowing nursery of star formation, where new suns are being born from clouds of dust and gas. It is 1,300 light-years away. The light we see tonight left the nebula before the fall of Rome. It has been traveling while empires rose and crumbled, while maps were drawn and redrawn, while humanity spread across the globe. All that history passed in the blink of an eye for the light beam as it rushed toward us. Every time we look at a different star, we are looking at a different depth of time. The sky is not a flat canvas. It is a deep, three-dimensional history book. The farther we look, the further back we read. We are time travelers standing still. We are archaeologists of the sky, digging into the past with our eyes. And the light year is our shovel. It is the tool that allows us to make sense of the layers. It tells us that this star is from the last decade, and that star is from the last millennium. It organizes the chaos of the night into a structured timeline. It turns the static dome of the heavens into a flowing river of time. So let us drift a little longer here, in the quiet space between the Sun and Alpha Centauri. Let us appreciate the 4 years of emptiness that separate us. It is a buffer zone, a quiet place, a place where nothing happens and where everything is possible. The light passes through, silent and steady, weaving the universe together, 1 year at a time. The City of Silence. We have learned to accept the distance to our neighbors. We have accepted that 4 years of light travel separates us from the nearest star. But in the grand design of the cosmos, 4 light-years is merely the width of a single room. We are now ready to step out of the house entirely and look at the city in which we live. This city is the Milky Way galaxy. When we look up on a very dark night, far away from the lights of human cities, we see a faint glowing band stretching across the sky. It looks like spilled milk, a river of pale light flowing through the darkness. The ancients saw it as a pathway for the gods or a celestial river. But what we are actually seeing is the collective light of billions of stars, so distant and so numerous that they blur together into a single haze. We are looking edge-on into the disk of our own galaxy. The Milky Way is a spiral galaxy. If you could fly millions of light-years above it and look down, it would look like a slowly spinning pinwheel. It has a bright, dense center, glowing with a golden light. From this center, great arms of dust and gas and blue stars curve outward, spiraling into the blackness of intergalactic space. It is a thing of immense beauty, but it is also a thing of immense size. To cross the Milky Way, from one edge of the disk to the other, light must travel for 100,000 years. 100,000 light-years. Let that number settle. We struggled with 4 years. We tried to imagine the patience required for a beam of light to travel for 4 years. Now we must imagine that same beam traveling for 1,000 centuries. It leaves a star on the outer rim of the galaxy. It flies through the emptiness. It passes nebula after nebula, star cluster after star cluster. It watches civilizations rise and fall on 1,000,000 different worlds. It watches species evolve and go extinct. It watches mountains wear down to sand. And still it travels. It is not even halfway across. 14.
100,000 years is the entire history of modern humanity. When the light started its journey across the galaxy, our ancestors were just beginning to migrate out of Africa. They were using stone tools. They huddled around fires in caves, looking up at the same stars we see today, unaware of the light that was already rushing toward them. As that light crossed the spiral arms, we learned to farm. We built pyramids. We invented writing. We fought wars. We built cities of glass and steel. We flew to the moon. And only now, after all of that human struggle and triumph, does the light finally reach the other side. This is the scale of the Milky Way. It is a city of stars, yes, but it is a city built on the foundation of silence. It contains perhaps 200 billion stars, 200 billion suns. Some are smaller and redder than ours, some are massive blue giants that burn with a furious heat. But despite this staggering population, the galaxy is mostly empty space. If you were to randomly appear somewhere inside the Milky Way, the chances of you being near a star are vanishingly small. You would likely find yourself in the deep, cold dark between the systems. You would look around and see stars as distant points of light, just as we do from Earth. The galaxy is not a crowded room. It is a sparse archipelago. It is a collection of lonely islands separated by vast oceans of night. We live in one of the suburbs of this city. Our solar system is located in the Orion Arm, a minor spiral arm located about halfway between the center of the galaxy and the outer edge. We are about 26,000 light-years from the downtown core. This is a quiet neighborhood. The stars here are spread out comfortably. We are not buffeted by the intense radiation of the galactic center. We are not threatened by the chaotic activity of the dense star clusters. We are drifting in the calm waters of the galactic disk. But everything is moving. The galaxy is not a static painting, it is rotating. The entire spiral disk is spinning, turning slowly like a great wheel in the dark. But the speed of this rotation is measured in geological time. Our sun and all the planets with it are orbiting the center of the galaxy. We are moving at a tremendous speed, hundreds of thousands of kilometers per hour. But the distance we have to cover is so vast that the motion seems imperceptible. It takes the sun roughly 230 million years to complete one single orbit around the galaxy. This is called a galactic year. The last time the Earth was in this position in its orbit, dinosaurs were just beginning to appear on the planet. The continents were shaped differently. The Atlantic Ocean was just a narrow rift. The world was unrecognizable. Since then, we have traveled all the way around the wheel, a journey of nearly 160,000 light-years in circumference, and we have arrived back here. In the lifespan of our sun, which is about 4.5 billion years old, we have only circled the galaxy about 20 times. We are young travelers. The galaxy is ancient. It turns with a slow, heavy majesty that mocks our hurried sense of time. If we look toward the center of the galaxy, toward the constellation of Sagittarius, we are looking into the heart of the city. But we cannot see it clearly with our eyes. The center is hidden behind thick curtains of interstellar dust. These dust clouds hang in the spiral arms like dark fog, blocking the visible light from the dense cluster of stars in the core. If we could see through that dust, the night sky would look very different. The Milky Way would not be a faint band, it would be a blazing streak of fire, bright enough to cast shadows on the ground. The center of the galaxy is packed with old red stars, swarming around a supermassive black hole that anchors the entire structure.
But the dust protects us. It keeps the sky dark. It keeps the mystery. The light from the center takes 26,000 years to reach us. It fights its way through the dust, scattering and reddening until only the faintest glow remains. When we look at that glow, we are seeing the galaxy as it was during the last ice age. We are seeing the light that left a core when vast glaciers covered the northern hemisphere of Earth. And what of the other side? What of the stars on the far rim of the galaxy, 70,000 light years away? We will likely never see them. They are too faint, too distant, too obscured by the bulk of the galaxy itself. We share this city with billions of neighbors we will never meet. We are separated not by walls, but by time, by the sheer, insurmountable patience of light. There is a comfort in being part of something so large. It means that we are not the center of everything. We are just one small star in a vast river of stars. We are drifting along with millions of others, caught in the same slow current. The galaxy holds us. It protects us from the deeper void that lies outside. It is our island in the universe. And yet, even the Milky Way is just a speck. It feels enormous to us. 100,000 light years seems like infinity. But in the context of the universe, 100,000 light years is just a local measurement. It is the size of a single snowflake in a blizzard. As we drift here, suspended in the Orion Arm, looking out at the band of the Milky Way, we can feel the scale of the structure. We can feel the depth of the disk. We can imagine the stars above us and below us, forming a great glowing lens. We can imagine the spiral arms wrapping around us, cradling us in their dusty embrace. The silence here is different from the silence of the solar system. It is a deeper silence. It is the silence of a library that has been closed for 1,000,000 years. It is the silence of things that endure. The stars are burning their fuel, slowly, steadily. They are transmuting hydrogen into helium, pouring light out into the vacuum. They do not hurry. A star like our sun lives for 10 billion years. A red dwarf can live for 1,000,000,000,000 years. They have all the time in existence. And so, the light year becomes not just a measure of distance, but a measure of serenity. It tells us that the universe is not in a rush to go anywhere. It is content to simply be. It is content to let the light travel for 100,000 years just to cross a single galaxy. It is content to let the spiral arms turn once every 250,000,000 years. We are small, fleeting sparks watching a slow burning fire. And that is okay. It is relaxing to be small. It takes the weight off our shoulders. We do not have to carry the galaxy. We only have to ride it. We only have to drift with it, turning our faces to the dark and watching the ancient light arrive, soft and silent, from the depths of the city of stars.
16. The Archipelago of Light. We have spent a long time within the embrace of the Milky Way. We have explored the solar system with its light minutes, and we have drifted through the local stellar neighborhood with its light years. We have even imagined the vast spinning disk of the galaxy itself, spanning 100,000 light years from edge to edge. But now, the time has come to leave the city. The time has come to rise up, out of the spiral arms, out of the dust and the gas, and look back at our home from the outside. As we move away from the galactic plane, the view changes.
The band of the Milky Way, which once stretched across the sky like a river, begins to tighten. It becomes an island. We see the spiral structure clearly now. We see the glowing core, yellow and bright. We see the blue arms curving gracefully into the dark. We see the halo of globular clusters, ancient balls of stars hovering around the galaxy like moths around a street lamp. And then, as we continue to pull away, even this immense structure begins to shrink. The 100,000 light-years that seemed so impossible to cross becomes a small shape in the distance, a disk of light floating in a much, much larger ocean. We are entering intergalactic space, the space between galaxies. If interstellar space was a vacuum, this is something else entirely. This is the true void. The density of matter here drops to levels that are hard to comprehend. There is almost nothing here. Just a few stray atoms of hydrogen for every cubic meter of space. It is a silence so profound that even the stars seem loud by comparison. Here, there are no stars to warm us. There is only the deep, permeating cold of the universe and the faint, distant glow of galaxies far away. In this emptiness, the light year is no longer enough. We need to stack them. We need millions of them. We are no longer measuring the distance to the house next door. We are measuring the distance to the next town. And the nearest town of any size is a galaxy called Andromeda. From Earth, Andromeda is a faint smudge in the constellation of the same name. You can see it with the naked eye if the night is very dark and very clear. It looks like a tiny puff of cloud. But that puff of cloud is a spiral galaxy even larger than our own. It contains perhaps 1 trillion stars, 1 trillion suns swirling in a great disk, possessed of their own planets, their own histories, their own silences. And the distance to this neighbor? 2.5 million light-years. 2,500,000 years. That is how long the light has been traveling. When you look at that faint smudge in the sky, the photons striking your eye left the stars of Andromeda long before human civilization existed. They began their journey before the pyramids were built, before the first cities were founded, before language was spoken. They left Andromeda when our ancestors were still early hominids wandering the plains of Africa, using simple stone tools to scrape meat from bones. While that light was crossing the void, the ice ages came and went. The glaciers advanced across the continents and retreated again. Species evolved and vanished. The entire saga of human evolution, from those early tool users to the astronauts who walked on the moon, played out entirely within the time it took for a single beam of light to cross the gap between two galaxies. Think of the patience of that light. It left a star in the spiral arm of Andromeda. It flew out into the intergalactic dark. For 2.5 million years, it saw nothing. It touched nothing. It did not slow down. It did not degrade. It simply moved. It carried the image of its birth star through the silence, century after century, millennium after millennium. It crossed a darkness so deep that the human mind recoils from it. And finally, after that eternity of travel, it arrived here. It arrived to tell us that Andromeda is there. But it tells us that Andromeda was there 2.5 million years ago. We have no idea what is happening in Andromeda right now. A supernova could be exploding there at this very moment, a star tearing itself apart in a cataclysm of fire. But we will not know about it for another 2.5 million years. The news is in the mail. The universe has a speed limit, and it strictly enforces the delay. We are forever cut off from the present of our neighbors. We can only know their past. Andromeda and the Milky Way are not alone in this void. We are part of a small cluster of galaxies called the Local Group. It is a village in the dark. There is the Milky Way and there is Andromeda, the two giants of the group. Then there is the Triangulum Galaxy, a smaller spiral, roughly 3 million light-years away. And swarming around these three large galaxies are dozens of smaller ones, dwarf galaxies, irregular blobs of stars that look like spilled glitter. The Magellan Clouds, visible from the southern hemisphere of Earth, are two of these dwarf galaxies. They are satellite galaxies, orbiting the Milky Way just as the Moon orbits the Earth. They are close neighbors, relatively speaking, only 160,000 light-years away, practically on our doorstep. But even that short hop is a journey of human history.
17. The local group is held together by gravity. Even across these millions of light years, the galaxies feel each other. They are performing a slow, majestic dance. Andromeda and the Milky Way are actually falling toward each other. Gravity is pulling them together across the void. We are moving toward Andromeda at roughly 110 kilometers per second. It sounds dramatic, a collision of galaxies, but remember the scale. Remember the slowness. This is not a car crash. This is a merger of clouds. It will not happen for another 4 billion years. 4 billion years. The sun will be an old star by then. The Earth will be unrecognizable. And when it finally happens, it will not be violent. The stars in the galaxies are so far apart that they will likely not collide at all. The two galaxies will simply pass through each other, their shapes distorting, their spiral arms stretching out into long streamers of stars. They will swing past, slow down, and fall back together, eventually merging into a single, giant elliptical galaxy. It will be a quiet event, a dance of shadows and light played out over hundreds of millions of years. If anyone is there to watch it, the sky will simply grow brighter. The band of the Milky Way will be joined by the band of Andromeda. The night will be filled with twice as many stars. But for now, it is just a prediction. It is a future written in the slow mathematics of gravity. For now, we are just islands. We look across the millions of light years and we see the faint shapes of our neighbors. We see Triangulum, spinning silently 3 million years in the past. We see the dwarf galaxies drifting like debris. And between us lies the medium, the intergalactic void. What is it like out there, midway between the Milky Way and Andromeda? If we were to position ourselves exactly in the middle, 1.25 million light years from home, what would we see? We would see darkness. A darkness deeper than anything seen from Earth. The Milky Way would be a small, glowing disk in one direction, about the size of a saucer held at arm's length. Andromeda would be a similar disk in the other direction, and everywhere else, black. Absolute black. There would be no nearby stars, no planets, no sun. Just the distant, fuzzy patches of other galaxies, infinitely far away. It would be a place of perfect isolation, a place where you could float for 1 billion years and never encounter a single solid object. The temperature would be indistinguishable from absolute zero.
the silence would be heavy. It is a place where time seems to lose its meaning. Without the rising and setting of a sun, without the turning of seasons, without the ticking of a clock, what is a year? A year is just a measure of light traveling through nothing. And yet, light does travel. It fills the void. Even in the deepest darkness between galaxies, space is awash with photons. Light from the Milky Way is rushing outward. Light from Andromeda is rushing outward. Light from distant quasars and exploding stars is threading its way through the dark. The universe is a web of information. Every point in space is crisscrossed by the histories of a billion worlds flying past each other in silence. We are just catching the tiny fraction of that light that happens to hit our planet. We are standing in the rain with a thimble, catching a few drops and trying to guess the shape of the storm. The scale of millions of light years is hard to hold on to, but it is also liberating. It tells us that the universe is not crowded. It has room. It has so much room that entire galaxies can drift for eons without touching. It suggests that reality is mostly space, mostly potential, mostly waiting. When we think of the local group, we should think of it as a small archipelago in a vast ocean. We are on one island. Andromeda is on the next island over. The water between us is deep and wide. We can see the signal fires of the other island, but we cannot cross the water. Not yet. Maybe not ever. And that is fine. The distance makes the view beautiful. It turns the other galaxy into a jewel, a mystery, a painting of light that hangs in our sky.
We have now stepped out to the scale of millions of years. We have seen our local village. But the universe does not stop here. The local group is just one cluster. It is just one small knot of galaxies in a much larger tapestry. Beyond Andromeda, beyond Triangulum, lie the true deeps, the places where the numbers stop being millions and start being billions. The places where the light we see is so old that it comes from a time before the Earth was even formed. We are ready to leave the village. We are ready to look at the superclusters. We are ready to drift into the realm of the cosmic web, where galaxies are strung like pearls on invisible threads of dark matter. But for now, let us rest in the space between the Milky Way and Andromeda. Let us float in the 2.5 million year gap. Let the silence of the intergalactic medium wash over us. It is a clean silence, a pure silence, a silence that has lasted since the beginning of time. Part 6. The Great Attractors. We have drifted far from home. We have left the Earth, the Sun, and even the Milky Way behind. We have crossed the deep channel of silence that separates us from Andromeda. We have stood on the shores of our local group, that small, intimate gathering of galaxies huddled together in the dark. But now, we must adjust our eyes again. We must widen our gaze until even the local group becomes a single point of light. We are moving into the realm of the clusters. If the local group is a village, then out there, in the deeper dark, lie the cities. The nearest major metropolis to us is the Virgo cluster. To find it, we look past the constellation of Virgo in the night sky. To the naked eye, there is nothing there but a few faint stars. But through a powerful telescope, that patch of darkness explodes into light. It is a swarm. It is a beehive of galaxies. Where our local group has only 3 large galaxies, the Virgo cluster has thousands. 2,000 immense islands of stars bound together by gravity, buzzing around a common center.
The distance to this city is staggering. It lies roughly 54 million light-years away. 54 million years. Let us pause and let that number sink into the quiet. When we looked at Proxima Centauri, we were looking 4 years into the past. When we looked at Andromeda, we were looking back to the dawn of humanity. But when we look at the Virgo cluster, we are looking back to a different Earth entirely. The light arriving tonight from the Virgo cluster began its journey when the dinosaurs were still the masters of this world. It left those distant galaxies 54 million years ago in the chaotic aftermath of the extinction event that wiped out the great reptiles. While that light was traveling through the intergalactic void, the Earth was healing. The dust settled. Mammals began to emerge from the shadows, small and furry, evolving slowly into the forms we know today. The continents drifted apart. The Himalayas rose up from the collision of India and Asia. The ice caps formed. The first primates appeared in the trees. The first tools were struck. The first fires were lit. All of that history, the entire rise of the age of mammals and the age of man, happened while the light was simply flying through the empty space between Virgo and us. It is a silence that spans geological eras. The light carries the image of a cluster that existed when T-Rex bones were fresh. We have absolutely no way of knowing what the Virgo cluster looks like today. We are watching a movie that was filmed 50 million years ago. The cluster itself is a thing of terrifying beauty. It is dominated by giant elliptical galaxies, massive balls of old red stars that have grown fat by swallowing smaller neighbors. In the center sits Messier 87, a galaxy so large it makes our Milky Way look like a dwarf. M87 is a monster. It shoots a jet of high-energy particles thousands of light-years into space, a beacon powered by a black hole billions of times the mass of the Sun.
19. But even with all this energy, from here, 54 million light-years away, it is just a faint glow. It is silent. The violence of the black hole, the swirling of the thousands of galaxies, the gravitational dance, it is all reduced to a smudge of light that sits perfectly still in the eyepiece of a telescope. Distance erases the noise. It smooths out the chaos. It turns the fury of the cosmos into a painting. And Virgo is just the beginning. As we pull back further, we see that our local group and the Virgo cluster are part of something even larger. We are part of a supercluster. Imagine a web, a cosmic spider web made of light. The strands of the web are filaments, long chains of galaxies strung together across the void. The knots where the strands meet are the clusters, like Virgo. And in between the strands are the voids, immense bubbles of nothingness where almost no galaxies exist. This is the structure of the universe on the grandest scale. It is not a random scattering of stars. It is a foam. It is a sponge. Our home, the Virgo supercluster, sometimes called the local supercluster, is a lobe of this web. It spans 100 million light-years. 100 million. 500 million years of light travel. It contains 100,000 galaxies. It is our true home continent in the universe. We are just a tiny speck on the outskirts of Laniakea, drifting slowly toward its heart. Think of the stillness of that motion. The galaxies are moving at millions of kilometers per hour, pulled by the gravity of the great attractor at the center of the supercluster.
but the distances are so great that the motion is invisible. To us, the galaxies appear fixed. They are frozen in the amber of space-time. It takes billions of years for the shape of Laniakea to change even slightly. It is a sculpture made of light and gravity, suspended in the dark, evolving on a timescale that makes the life of a star seem like a flicker. In this realm of superclusters, the light year becomes a unit of texture. We talk about the density of the universe. We talk about the smoothness of the cosmic background. We are no longer looking at individual objects. We are looking at the grain of reality itself. We see that the universe is mostly empty space, punctuated by these thin filaments of light. The voids, the empty bubbles between the filaments, can be 200 million light-years across. Imagine drifting in the center of a void. You would be 100 million light-years from the nearest galaxy. The sky would be perfectly black. You would see nothing, no stars, no milky bands, just an endless, suffocating dark. You would be in the quietest place in existence. But even there, the light is passing through. The light from Laniakea, the light from Virgo, the light from the Milky Way, it is all crossing the voids, carrying the news of our existence to the other side. The universe is transparent. It hides nothing if you have the patience to wait for the light to arrive. There is a profound peace in thinking about Laniakea. It reminds us that we are connected. We are not isolated in a random corner of space. We are part of a flow. We are part of a great river of galaxies, all streaming together toward a destiny we will never see. Gravity is the invisible hand that holds us gently but firmly across 500 million light-years of emptiness. The scale here dissolves anxiety. It is too big to worry about. It is too big to be frightening. It is simply majestic. It is a reminder that the universe has a structure, an architecture that dwarfs our understanding. We are microscopic inhabitants of a cathedral that has no ceiling.
20. As we drift here, looking at the filaments of Laniakea glowing faintly in the distance, we can feel the weight of the years. 500 million years. When the light from the far side of Laniakea began its journey, complex life on Earth was just beginning in the oceans. The land was barren rock. There were no trees, no flowers, no animals walking on the soil. The entire story of life on land, from the first moss to the first forests, from the amphibians to the dinosaurs, from the birds to the mammals, to us, all of it has happened in the time it took for light to cross our home's supercluster. We are new here. We are very, very new. The universe has been humming its quiet song for eons before we arrived to hear it, and it will continue to hum long after we are gone. The galaxies will continue to flow. The light will continue to travel. The silence will endure. And so, we rest in the knowledge of our place. We are citizens of the earth, children of the sun, residents of the Milky Way, neighbors of Virgo, and travelers within the immeasurable heaven of Laniakea. We are small, but we are part of the whole. And the light year, that strange and stretchy ruler, helps us trace the lines of our connection to the dark.
We have seen the cities, we have seen the web, but there is still further to go. Beyond Laniakea, beyond the local structure, lies the rest of the universe. The deep field, the places where the light is so old it stretches back to the beginning of time itself. We are ready to look at the edge. But for now, let the 500 million years of Laniakea wrap around you like a blanket. It is a big space, a quiet space, a space for sleeping. The deepest dark. We have traveled so far that the Earth is not even a memory. The solar system is a grain of dust lost in the void. The Milky Way is a speck of light indistinguishable from millions of others. We have drifted through the filaments of Laniakea, the immeasurable heaven, and seen the great rivers of galaxies flowing in the dark. But even this is not the end. There is a further, there is a deeper. To understand the true scale of the light year, we must look at what happens when we simply stare at the darkness. In 1995, astronomers made a decision that seemed, on the surface, to be a waste of time. They took the Hubble Space Telescope, the most powerful eye humanity had ever built, and they pointed it at a patch of sky that appeared to be completely empty. It was a tiny speck of darkness near the handle of the Big Dipper. It was a patch of sky about the size of a grain of sand held at arm's length. From the ground, through ordinary telescopes, there was nothing there. Just black space, no stars, no galaxies, just a void. They opened the shutter of the camera and they let it stare at that emptiness for 10 consecutive days. They let the faint, weary light from the deepest reaches of the universe soak into the sensors. They waited. They gathered photons that had been traveling for eons. And when they finally closed the shutter and processed the image, the darkness was gone. The image was not black. It was a kaleidoscope. In that tiny grain of sand, in that speck of nothing, they found 3,000 galaxies. 3,000 entire cities of stars. Spiral galaxies like our own. Elliptical galaxies glowing like embers. Irregular galaxies shaped like shipwrecks. They were scattered across the image like jewels spilled on black velvet. And they were all sitting in a patch of sky that we thought was empty. If you were to hold a grain of sand up to the sky at any point, in any direction, and look deep enough, you would find the same thing. The universe is wallpapered with galaxies. There are perhaps 2 trillion of them in the observable universe. 2 trillion islands. And between them, the distances are measured not in millions of light years, but in billions.
When we look at the galaxies in that deep field image, we are looking at distances of 10, 11, 12 billion light years. 12 billion years. It is a number that creates a hush in the mind. The universe itself is estimated to be about 13.8 billion years old. When we look at light that has been traveling for 12 billion years, we are looking at the baby pictures of the cosmos. We are seeing galaxies as they were when the universe was just a toddler. These galaxies do not look like the Milky Way. They are smaller, messier, more chaotic. They are still forming. We are watching them in the act of being born. We are seeing clouds of gas collapsing to form the first generations of stars. We are seeing the universe assembling itself, piece by piece, in the dark.
But remember the delay. The light year is a time machine. Those galaxies we see in the deep field, they aren't there anymore. Not in that form. Over the 12 billion years that their light has been traveling to us, they have collided, merged, grown, and aged. They have become majestic spirals or giant ellipticals. The stars that were being born in that light have long since lived their lives and died. They have exploded as supernovae, seeding the space around them with carbon and oxygen and iron. New stars have formed from that dust. Planets have formed. Perhaps life has risen and fallen 1,000 times over. But we cannot see any of that. We can only see the toddler. We can only see the ancient past. The present reality of those galaxies is lost to us, hidden behind the unsurpassable barrier of light speed. We are separated from them by an ocean of time so vast that now loses its meaning. There is no now that we can share with a galaxy 12 billion light years away. There is only their past and our present. This deep view brings us to the concept of the observable universe. This is the ultimate horizon. It is the edge of our vision. It is not the edge of the universe itself. Space likely goes on forever beyond it, but it is the edge of what we can see. Why is there an edge? Because the universe has a birthday. It began roughly 13.8 billion years ago. This means that light has only had 13.8 billion years to travel. If a star is far enough away that its light takes 15 billion years to reach us, we cannot see it. The light hasn't arrived yet. It is still on its way, rushing through the dark, but it hasn't reached Earth. We are standing in the center of a bubble of light. The bubble is defined by the age of the universe. We can see everything inside the bubble, but nothing outside it. And every year that passes, the bubble gets a little bigger. We can see 1 light year further into the dark. We are slowly, patiently uncovering the rest of the universe, 1 year at a time. But there is a twist, a quiet, strange twist to this story. The universe is not just sitting still while the light travels. The universe is expanding. The space between the galaxies is stretching. Imagine drawing 2 dots on a balloon and then blowing it up. The dots don't move across the rubber, but the distance between them grows. That is what is happening to the galaxies. The space itself is getting bigger. This means that the light from those distant galaxies has to run a marathon on a track that is lengthening while it runs. It has to travel farther than it expected. A galaxy that looks like it is 12 billion light years away is actually much, much farther away by now. Because while that light was traveling for 12 billion years, the space expanded. That galaxy is now roughly 46 billion light years away from us. 46 billion light years. That is the radius of our visible world. That is the distance to the horizon. If we could freeze time and travel instantly to that edge, what would we find? We would find more galaxies, more stars, more silence. The universe does not seem to end. It just continues, vast and uniform in every direction. We are simply limited by the speed of light. We are limited by patience. There is something deeply relaxing about this limit. It tells us that there are things we cannot know. There are places we cannot see. There are distances we cannot bridge. The universe keeps some of its secrets. It hides them behind the curtain of distance and time.
22. When we look at the deep field, at those thousands of faint smudges of light, we are looking at the deepest silence of all. We are looking at the era before the earth existed, before the sun existed. We are looking at the lonely, early days of creation. The light is faint.
stretched thin by its long journey, weary and red. It lands on the mirror of the telescope as a mere whisper. And yet it arrived. It made it. It crossed the voids. It dodged the dust clouds. It survived the expansion of space. It held on to its information for 12 billion years, just to deliver a tiny packet of photons to a small blue planet orbiting a yellow star. It feels like a gift. A message from the deep past saying, "I was here. I existed." As we drift in this mindset, contemplating the billions of years, the anxieties of the present moment dissolve completely. What is a deadline? What is a traffic jam? What is a restless night compared to a journey of 12 billion years? The light year is a perspective engine. It shrinks our worries until they're smaller than atoms. It allows us to float in a sea of time that is so deep we can never touch the bottom. We are suspended in the center of a sphere of history. Everywhere we look back. We are surrounded by the ghosts of the early universe. They watch us from the dark, silent and still. They are the ancestors of the night sky. And they are beautiful. Not because they are bright, they are the faintest things we can see, but because they are enduring. They are the light that refused to go out. So let us rest here, at the edge of the observable. Let us float on the horizon, 46 billion light years from home. The view is endless. The darkness is soft. The silence is absolute. We have reached the limit of our vision, but not the limit of our imagination. We can close our eyes and let the rest of the universe unfold in our dreams, unseen, unheard, but undeniably there. The universal clockwork. We have traveled to the edge of the visible universe. We have looked back billions of years into the past. We have felt the immense silent weight of the light year as it stretches across the voids. But there is a question that lingers underneath all of these distances, a question that sits at the very heart of the concept. Why is the speed of light what it is? Why does it take time to get anywhere? Why isn't the universe instant? To understand this, we must stop looking at the stars for a moment and look at the fabric of space itself. We must look at the rules of the road.
23. The speed of light, that familiar figure of roughly 300,000 kilometers per second, is not just the speed of a photon. It is often called the cosmic speed limit, but even that phrase feels too focused on travel. It suggests a policeman waiting to give a ticket to a speeding electron. The reality is far deeper and far more serene. This speed is the speed of causality. It is the speed of cause and effect. It is the maximum speed at which two things in the universe can talk to each other. It is the speed at which reality updates. Imagine the universe as a calm, still pond. If you drop a stone into the water, the ripples move outward. They do not appear at the edge of the pond instantly. They have to travel. They have to push the water molecules next to them, which push the next ones and the next ones. The disturbance spreads. The speed of light is simply the speed of the ripple in the fabric of the universe. This limit is what gives the universe its order. It is what prevents everything from happening at once. If light traveled infinitely fast, if information could move instantly from one end of the cosmos to the other, the universe would be a chaotic, overwhelming place. Every event,
everywhere would be connected to every other event immediately. There would be no separation. There would be no privacy. There would be no here and there. Everything would be a singular, noisy now. But the speed of light slows everything down. It creates buffers. It creates local realities. It ensures that what happens in the Andromeda Galaxy stays in the Andromeda Galaxy, at least for 2.5 million years. It insulates us. It wraps us in a blanket of delay. There is a famous thought experiment that illustrates this beautiful disconnection. Imagine, for a moment, that the sun simply vanished. It didn't explode, it just disappeared from existence, plucked out of the sky by a giant cosmic hand. What would happen on Earth? Logic suggests that since the sun provides the gravity that keeps us in orbit, we would immediately fly off into deep space. Logic suggests that since the sun provides our light, the sky would immediately go black. But the universe does not follow that logic. The universe follows the speed of light. For 8 minutes and 20 seconds after the sun vanished, nothing on Earth would change. The gravity that the sun created is a curvature in space, a ripple. That ripple travels at the speed of light. The last stream of photons emitted by the sun travels at the speed of light. So for those 8 minutes, the Earth would continue to orbit a star that was no longer there. We would feel the gravitational pull of a ghost. We would see the sunlight of a ghost. The flowers would continue to photosynthesize. The solar panels would continue to generate electricity. People on the beach would continue to feel the warmth on their skin. The reality of the sun's disappearance simply hasn't arrived yet. It is traveling through the post. Then, at the 8-minute mark, the news arrives. The sky goes dark. The gravitational tether snaps. The Earth flies off in a straight line into the night. Reality catches up. This delay is not a flaw in the system. It is the system. It means that we are always living in a bubble of now that is determined by distance. The further away something is, the more disconnected its reality is from ours. This limit applies to everything. It applies to gravity. It applies to magnetism. It applies to the very forces that hold atoms together. It is the heartbeat of physics, and it is incredibly precise. The speed of light is not roughly 300,000 kilometers per second. It is exactly 299,972,458 meters per second. It is a fundamental constant, a number hard-coded into the operating system of reality.
24. There is a sense of reliability in that number. It never changes. It doesn't matter if you are shining a flashlight from a moving train or from a stationary platform. The light always leaves you at the same speed. It doesn't matter if you are looking at a star from Earth or from a spaceship moving at half the speed of light. The light coming from that star strikes your window at the exact same speed. Light is stubborn. It refuses to be relative. Space and time will bend and warp to accommodate light, but light will not change for them. If you try to catch up to a beam of light, time will slow down for you. Space will compress for you. The universe will twist itself into knots just to ensure that the light remains faster than you. This leads us to one of the most relaxing, sleep-inducing concepts in all of physics, the photon's perspective. We have spent this entire journey talking about how long it takes light to travel. We have said it takes 8 minutes to get from the Sun, 4 years from Proxima Centauri, 2 million years from Andromeda. But that is our perspective. That is the view from the waiting room. What does the journey feel like for the light itself? According to the laws of relativity, as you move faster, time slows down. If you could move at the speed of light, time would stop completely. This means that for a photon, a particle of light,
There is no time. It does not experience duration. It does not wait. The moment a photon is born in the core of a star and the moment it hits your eye a million years later are, to the photon, the exact same moment. For the light coming from Andromeda, the journey does not take 2 million years. It takes 0 time. It is instantaneous. One moment it is in the star, the next moment it is in your eye. It does not experience the distance. It does not experience the void. It creates a bridge where the beginning and the end touch. This is a strange, dreamlike thought. The universe is full of these particles that are timeless. They weave through the cosmos, stitching together the ancient past and the present moment, oblivious to the years that pass for us. To them, the universe is small. To us, it is vast. Both are true. It just depends on how fast you are moving. There is a deep calm in this paradox. It suggests that time is flexible. It suggests that the long, weary wait of the light year is just a local experience. It is a product of our mass, our heaviness, our slowness. We are creatures of matter, and so we must wait. Light is pure energy, and so it is free. This universal clockwork also provides a safety limit. Because nothing can travel faster than light, we are protected from causality violations. We cannot receive a message before it is sent. We cannot see the glass break before it falls. The flow of time is preserved by the speed limit. It keeps the story of the universe moving in one direction. It keeps the narrative clean. Imagine if there were no limit. Imagine if things happened instantly. The universe would be a cacophony. But the speed of light acts as a cosmic dampener. It spaces things out. It ensures that events unfold in a sequence, like the pages of a book turning one by one. You cannot read the last page before you have read the first. The light year is the thickness of the pages. So when we look up at the night sky, we are not looking at a chaotic jumble. We are looking at a perfectly synchronized machine. The light arriving from the moon is 1 second old. The light from Jupiter is 40 minutes old. The light from Sirius is 8 years old. The light of the belt of Orion is 1,000 years old. Everything is arriving exactly when it is supposed to. Nothing is late, nothing is early. The traffic of the cosmos is flowing perfectly. The speed of light is the conductor of this symphony. It holds the baton. It tells the nebula when to be seen. It tells the supernovae when to appear. It organizes the timeline of 2 trillion galaxies into a coherent visual experience for the observer on Earth.